This is Mr. Martin. These are video notes for Geometry Advanced, section 12.4. We're going to be talking about law of cosines. So in the last section, we looked at law of sines, which was one method for solving oblique triangles. Remember, oblique triangles are non-right triangles. Okay, and again, when we say solve a triangle, we're talking about finding the remaining parts. So typically, with an oblique triangle, we'll be given 3 parts, and you have to find the other 3 parts. So here's our generic triangle, triangle ABC, and remember the sides that match the angles are opposite each other. And it's pretty important that you understand that we use capital letters for the angles. So here's capital A, B, and C, which refer to angles A, B, and C, the 3 vertices of the triangle. And then we use lowercase letters for the sides that go with the angles. So here's lowercase a, b, and c. And the side that corresponds to the angle is opposite it. So angle A is clear across the triangle from side A. Angle A and side A are opposite each other in the triangle. So make sure you're consistent with that notation, in particular when you're writing out your formulas. So there are proofs of these formulas, but it's beyond the scope of this class, so we're not really going to talk about it. And I know these look kind of scary, but it's not too bad. We have 2 forms of the law of cosines. So the first form is for finding side lengths. Okay, remember the lowercase letters represent the side length. So we have these formulas. This would be for finding A, and this would be for finding B, and this would be for finding C. And if you notice, these are squared. So your very last step at the end would be to take the square root. So let's make a little note here. Don't forget to take square root at end. Okay, because we don't want a squared, we want a, so we just take the square root at the end. Now, if I take these 3 formulas here and I solve it for cosine A, cosine B, and cosine C, I'm going to end up with the formulas over here on the right that we use for finding angle measures. Okay, we really only need to have these one set of formulas on the left, and if we want to find an angle, we would just solve for it. But it's easier if we have it already solved for A, B, and C. And then if you notice, if I substitute in the lengths of my sides for each of these, I would get the cosine of A. So I would get the ratio of the adjacent over the hypotenuse, or the cosine of B, or the cosine of C. So in order to get A, B, and C, our very last step, let's make a note here. Don't forget to take the cosine inverse. Okay, that's cosine to the -1 at end. Okay, because we want to actually solve for the angles. We don't want the ratio. Okay, so let's take a look at a couple of examples, and then I'm going to you can try the practice problems at the end of the packet. So I'm given that A is 5 centimeters, C is 7 centimeters, and B is 70 degrees. So I'll usually just draw my same generic triangle. Doesn't really matter how you draw it, just make sure you label it appropriately. So I'm going to do A, B, C, and then this would be side A, this would be side B, and this would be side C. And then I'm going to label in everything that I know. So I know that this is 5 centimeters, and this is 7 centimeters, and I know that this angle in here is 70 degrees. Okay, so if you notice, what we have here is we have 2 sides and the included angle. And before I go any further, I'm going to make my little answer table here. So I've got angles A, B, and C, and I need sides A, B, and C. And this will be required when you take the test. So angle B is 70 degrees, and then side A is 5 centimeters, and side C is 7 centimeters. Okay, so if you notice something different than the last section when we did law of sines, I don't have any angle on the side that goes with it. So I only have side A, I don't have angle A. I only have angle B, but I don't have side B. And I only have side C, but not angle C. So this is a pretty clear way to see that I'm not going to be able to use law of sines, at least not yet, and that you're going to want to use law of cosines. So in my picture I can say I have two sides in the included angle, and what I'm going to do is I'm going to find side B. So if I go back and look at my formulas, I see that b squared is a squared plus c squared minus 2ac times the cosine of angle B. Because I have a and c, and I also have angle B, so I have everything I need in this formula. So I'm going to go ahead and substitute everything in. I've got 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 70 degrees. And if I plug that all into my calculator, I should get 50.05. Again, keep in mind this is b squared. So now b is going to be the square root of 50.05, which is 7.08 centimeters. So let's go ahead and fill that in, 7.08 centimeters. Okay. So that takes care of that. Now we need to find another angle, and once I find a second angle, I can just subtract the two I have from 180 to get the third. So if you notice back up here, these three formulas for the angles involve the lengths of the three sides. So this has A, B, and C, this has A, B, and C, this one has A, B, and C. So if you have the three sides of a triangle, you can use the angle formulas to the law of cosine angle formulas to find an angle. So let's go ahead and use the one for cosine A. So I've got cosine A is equal to b squared plus c squared minus a squared over 2bc. Alright, and let's substitute in all the sides. I've got 7.08 squared plus 7 squared minus 5 squared over 2 times 7.08 times 7. And be careful when you substitute this in. Check on your calculator and make sure you get 0.7478. Now anytime you have trig ratios, if you're looking for the cosine, the sine, or the tangent of an angle, make sure you go out to at least 4 decimal places to get a more accurate answer. Alright, if you don't go out to 4 decimal places, I'm going to deduct a little bit because your answer is not going to be that accurate. Okay, so the cosine of A is equal to this. So in order to find A, we have to take the cosine inverse of that answer. So 7478, cosine inverse, and that should give us 41.6 degrees. Alright, and now that I have two of the angles, 41.6 degrees, all I have to do to get angle C is subtract the two that I know from 180. So 41.6 plus 70, and that should give me 68.4 degrees. Okay, so we've successfully solved this triangle. If you have any questions, make sure that you write those down, or if you happen to be watching in class, just pause your video and call me over to answer your question. And make sure you're doing enough practice on these so you can get a good handle and it doesn't take you too long on the next quiz or test. And we'll see you next time.